Hi grade 12s and welcome to this video. In this video, we're going to be going through the grade 12 Mathematics Paper 1 NSC final November exam, and this is for 2022. So remember that this is in preparation for the exam that you're going to write on Friday, the 3rd of November 2023. Okay, so it's again the usual. The total marks is 150 and it is 3 hours. So make sure you plan your time very effectively. Okay, so just remember that wherever they do not tell you to, just round off to two decimal places. So as long as they don't tell you round off to this amount, then by default, just round off to two decimal places. And write neatly and legibly and so on. So we can go ahead and move on to the first question. We have question 1.1.1. Okay, so this is the first question that we have. We have to solve for x, and we have 3x minus 6 multiplied by x plus 2 is equal to 0. You see that this is for 2 marks. Usually it's for 3 marks because there's a step where you have to factorize, but they factorized it for you. So all you have to do is, you see that you have your factors, you see that one hand side is already equal to 0. Just go ahead and equate your factors to 0. So we're just going to say that 3x minus 6 is equal to 0, or x plus 2 is equal to 0. And then we're going to take negative 6 over, and we have 3x is equal to 6. Divide both sides by 3 to solve for x, and therefore x is equal to 2. Over here, we're just taking that positive 2 over, and so we would just get that x is equal to negative 2. And so there are our solutions. Okay, moving on to the next question. Okay, and then the next question, 1.1.2, as you can see, we have another trinomial, but they tell us we need to correct to two decimal places. So that means you have to use the quadratic formula, because anything that has decimals, then you know that you don't have factors that are integers. Okay, so with this one, they've already put it in standard form, which is great. So you have on the right-hand side a 0. So we're just going to establish what a, b, and c are. So this is in the form of ax squared, of course, plus bx plus c. So we can see this is a as 2, b is negative 6, and c is 1. So let's just put down the quadratic formula. Remember, this is in your formula sheet. So x is equal to negative, and then we open a bracket, b is negative 6 plus minus the square root of negative 6 all squared, and then minus 4, and we have a as 2, and c, as 1, all over 2 multiplied by a, which is 2. And then you can just nicely put this onto the calculator. I will start with the negative, just because it's usually the smaller factor, and then the positive. Okay, and when I put it onto the calculator, I started with a negative. I get a 0,177, so you're going to round off to two decimal places, so that is going to be 1/8. Or x is equal to, and we're just going to change that to a plus sign, and we have x is equal to 2.822, so that just stays 8.2. Okay, so those are our solutions for this question. Moving on to the next question. Also, just remember, your mark allocations go here for your substitution, correct substitution, and for your two answers. Okay, they don't really give you a mark for this because you have a formula sheet. Likewise, with this one, your marks would really just go here and here because they factorized it for you already. Okay, 1.1.3, we have an inequality. We have x squared minus 90 is greater than x. And this is for 4 marks. Remember, in order to solve for the inequality, it's like an equation. So first of all, you need to get it in standard form. So I'm going to take this x to the left-hand side, and we have x squared. And I'm immediately going to put it here so that it is in its standard form. So that becomes minus x, and then minus 90 is now greater than, we have nothing here, and that's 0. Okay, this is what we have. We have two factors, and we just have to factorize this. Now, you can go ahead and start looking for the factors, or you could just use the quadratic formula to find your factors, okay? But you're going to pretend that you actually factorized it. So you create two brackets, then greater than 0. Then on your calculator, this is what you can do. Okay, we already have the quadratic formula, so I'm just going to substitute these values. So remember, we have negative b, so that's our b value. So here, our b value is negative 1. So I'm just going to put in negative 1, And then here we should have b squared. So that's negative 1 squared. Then minus 4 and then the 2. So remember that is 4ac. So that's a. As you can see here, a is 1. So we're going to put 1 in there. And c is negative 90. So I'm going to put negative 90 there. Then on the denominator, we should have 2a. So a is 1. So I'm going to change that to 1. So you see what I get? And look at how you're going to put the answer in. This is solving for x, okay? That's not just going to be the number here. Here you're going to have x multiplied by x. And then you're going to have your factors of negative 90. Here we got 10 because this is solving for x, meaning x is equal to 10. But you need to get the factor. So what I'm going to do, it's like taking 10 over. So it's like x minus 10. That is your factor. Okay, this was solving for x. But here is your factor by taking 10 over. So that's minus 10. And then for the other factor, you can just change the sign and you'd find it. So I change that to a minus now. And I get negative 9. Again, it's solving for x. It's saying x is equal to negative 9. So if you take that over, then that is actually x plus 9. So that's your factor, x plus 9. Just make sure you don't really show them this part, because then it's just going to defeat the whole purpose of you pretending to factorize. Okay, so there, that's what you're just going to have to do. So we have those now, and now we can go ahead and try and solve for x. Okay, so our critical values is really just like solving for x. X minus 10 is equal to 0. You take negative 10 over. Our critical values are positive 10 and negative 9. But instead of writing down the critical values, I'm not going to do that. I'm just going to put down x and then my critical value, which is positive 10. Or then I have x and my critical value, taking that over, is negative 9. And I'm just going to solve for the inequality so that I can just put the signs in straight away. Okay, so there are two ways for solving for inequalities. There is a grade 11 method, and then there's a method that is generally taught to grade 12s. I'm going to use the grade 12 method here. So all we're going to do is we're looking at the original inequality. Okay, this function is a parabola, and as you can see, the value of a is positive. So this is a concave up parabola. So this is what we have. We have a parabola like this, and all you're going to have to do now is draw an x-axis. And now that you've drawn the x-axis, you're going to put down your critical values in the places they're supposed to be. First critical value is negative 9. That is smaller than 10, so it should be on the left. So I put negative 9 here, and then I put 10 over here. And now we're going to just follow what the inequality is saying. So the inequality is saying that this function needs to be greater than 0. This graph, okay? We need to look for the places where it is greater than 0. So when it is greater than 0, this is referring to the y values. Now, you don't really need a y-axis for this, but I'm just going to put it just to explain this briefly. When we're saying greater than 0, we're referring to the y values of the graph that are greater than 0. As you can see, a y-axis has two parts. It has the part that is greater than 0 and the part that is less than 0. So we're looking for the part that is greater than 0. You're going to look at the graph and look at every part of the graph that has y values greater than 0. So if we're marking that out, you see that on the y-axis, these are the values greater than 0. Look at the graph. If I point it over there, you see that this point on the graph, it has a y value that is greater than 0. This point over here also has a y value greater than 0. All of these points have y values greater than 0. If you move downwards, you see that this point, it has a y value less than 0. So we're not going to include that. I'm not going to highlight that because that's not part of our solution. And all the way around here, I can't include any of these because they all have y values less than 0. I'm looking for y values greater than 0, like the inequality says. And if you look over here, you see that this point, it also has a y value greater than 0. Also has a y value greater than 0 all through. Okay, so this is really what we're going to highlight. I'm only going to be taking, and this is why I said I don't really need the y-axis. I'm going to just erase all of this. All I really am going to highlight is the part of the graph that has y values greater than 0, which would really just be this. Let me just get that out. Okay, so this is really the only thing. It would be over here and over here. So this is something that you can now make a note for yourself. Just remember, whenever they say greater than 0, you're just going to take all the parts of the graph that lie above the x-axis. Okay, so greater than 0 is for above the x-axis. And if they ask for less than 0, you look below the x-axis. So we're only taking these parts. And now we're going to have to find out. So this is just the part of the graph. We need to solve for x. What are the x values that belong to these highlighted parts? Well, to find those x values, I'm going to take each part of the graph and I will line it down to the x-axis and line that down to the x-axis. And now I see that the solution that I'm getting, if we look at that in terms of x, these are values that are, so this is -9 here, these are values that are less than -9. Okay, they're moving in this direction. And this will help you a lot when you see the direction that it's moving. So for x versus -9, I'm saying that x is less than -9. And here's where I say that inequality will help you. I want to say that x is less than -9. You will notice that the inequality and the arrow in which your solutions are facing is going to look exactly the same. So again, I'm going to line these highlighted parts of the graph down to the x-axis so I can understand their x values. And as you can see, the direction that it's going in the values that are greater than 10. Okay, this is 10 and the solutions are values moving towards the right. So I say x is greater than 10. And again, that inequality, the arrow helps you with the inequality. Okay, and that is how to solve for this. Lastly, just check if there is any relation. When I mean relation is, are these values related? Are they pointing towards each other? As you can see, this one is pointing to the left, that one is pointing to the right. They are pointing in complete opposite directions. They're not pointing towards each other, so we can leave the answer like that. We don't have to write it together like something like that, okay? This is not that case. So you leave the answer like that because they're not related. Okay, moving on to the next question. Okay, and now we are on question 1.1.4, and this is what we have. We have this equation with a surd in it. So whenever you see equations with surd, your one goal, especially if the surd has an x in it, you should try to isolate the surd. Now let's look at the best way to isolate this surd. Well, right now, as you can see, this surd, okay, it is negative. You always take the sign in front of it. It's a -7 square root of x. Because it's negative, we can make it positive. We're trying to isolate it, yes, but we can just take it over and leave it alone on this side so that it can also be positive. And then, because we want to leave the surd alone, we can take over the -12 to the left-hand side. So we're going to have x, and then the 12, that -12 comes over, plus 12 being equal to, that goes over and becomes +7 square root of x. Okay, now that it's in this format, you have isolated the surd, you get a mark for that. And then we're going to square both sides to get rid of that number over there. So we're going to square and square. Now when we square both sides here, you can go ahead and simplify this out if you like. You can go and do this method where you say x plus 12 multiply by x plus 12, but this takes too long. So I just work with a quicker method where I take the first term, I square that, that's x squared. And then I'm going to say the first term times the second term, which is 12x, but then you're going to multiply that by 2, which is +24x. And then to get the last term, you just square the last term, which will be +144. Okay, so that's how we expand that. It's equal to, we have 7 and the square root of x. When you are squaring this, this is what happens. So think about it like this. The 7 and the square root of x are next to each other because they're really being multiplied by each other. Just like if you had 2x all squared, the squared would apply to the 2 and the x. That's exactly what's going on here. It's going to apply to the 7 and the square root of x. So when it applies to the 7, if you have 7 squared, okay, that becomes 49. And here, if you square that root, the roots will cancel. And now you're left with just an x. Okay, and that's where we get that from. And so we can have x squared and then plus 24x. And you can already see this is going to be a trinomial. So let's take this over. So that becomes negative 49x, and then plus 144 is equal to 0. Then we have x squared plus 24. Okay, so we have to calculate this. So what is this going to give us? What is 24 minus 49? 24 minus 49 gives us, okay, negative 25. So minus 25x and then plus 144 is equal to 0. Okay, then we have to factorize this. So we can go ahead and open up two brackets. You can use that quadratic formula method to factorize this. So I'm going to put down x, and then 144. I need factors of 144 that can give me negative 25. But you have to remember that, you see, the middle term is the only negative one. When the last term is positive and the middle term is negative, then it means you're going to have a negative and a negative here, because that's the only other way that you can get a positive here. Remember, you're saying this multiplied by this gives you the positive 144. Okay, the fact that it's positive, it means that these two were negative, and we know that because the middle term is negative. Okay, so the factors of 144 that can give you 25, negative 25, you can go ahead and try these. Okay, you can also use the quadratic formula method, but I'm just going to try it out. Okay, so when trying numbers, okay, try 2, 3, 4, they were not working, okay, until I got to 9. So 144 divided by 9 gives you 16. And remember, they're both going to be negative. So you're saying that we have negative 9 and minus 16. And negative 9 minus 16 gives you negative 25. So that works out. So I'm going to use those factors. I have negative 9 minus 16. Okay, so this is just an equation. We have to just solve for x. So here, x is either equal to positive 9 or x is equal to positive 16. Okay, now that we have this, that's really how we solve. But there's one thing that I want you to actually always do, and this is usually for the case where you have 5 marks. I know it's 4 marks here, but do check if your answers are correct. So you can take your equation as it was. In place of x, I'm just going to put nothing. So x is going to go here, minus 7, the square root of x, and then is equal to negative 12. Okay, and I'm going to substitute these two values. Okay, first of all, 9 into this equation just to see if it balances out, if the right hand side really is equal to the left hand side. So if we put that in, and I say 9 over here and 9 over here, let's see what we get. As you can see, we get negative 12. So that perfectly balances. So we know that x really is equal to 9. Then we can also try that with the 16. You see, there's no need to even write this down. You can just check on your calculator to make sure that both answers are actually your solutions. So if I try that with 16, then, try that with 16. You see, we also get negative 12. So in this situation, both answers are correct. This is why when you are checking for if your answers are valid, don't just try one and then when you see that one works, reject the other. Don't do that. Try both of them to make sure that they actually do either work out or maybe one doesn't. Because you see, you can have situations where both of them are your answers. You can also have situations where none of them are your answers. And then you can have those normal situations where one of it is your answer and the other is not. Okay, so that is it for 1.1.4. Moving on to the next question. And now 1.2 says solve for x and y simultaneously, and this is what we've been given. Two equations. Now, look at your equations. The first equation, as you can see, is a linear equation, okay? The other one is not really linear. This is more like a hyperbolic equation. Always spot the linear equation and you're going to start with that one. You can call that equation 1, and then the second one by default is equation 2. We're going to start with equation 1 and we're going to form equation 3 from this. So 2x minus y being equal to 2. And then we can take this y over, because it's negative, we can just take that over to make it positive and bring the 2 over to this side. So we're going to have y here, positive y, and 2x, and then that becomes a minus 2. Now this is your equation 3. Now in order to solve for x, we're going to go ahead and substitute equation 3 into equation 2, the equation that you did not use. Okay, so substituting equation 3 into equation 2, you're taking equation 2 and wherever you see y, you're going to replace it with 2x minus 2. So as you can see, we have x and then we have y. So in place of y, put a bracket because it's being multiplied. We put 2x minus 2 is equal to 4. And now we're just going to solve for x here. So you can distribute this x into the bracket because we just have a 4 here. So that's going to be 2x squared and negative 2x. And I can already see this is going to become a trinomial. So I'm going to take the 4 over to the left hand side and it becomes a minus 4 is equal to 0. In this trinomial, notice that 2 is common in every term. Okay, so we have a common factor of 2. So we can just divide both sides of the equation by 2. And so now we have x squared minus x and then minus 2 is equal to 0. Then we have to factorize this, and this is a simple one to factorize. Open up 2 brackets is equal to 0. And you can use the quadratic formula, but just don't show them so that if they are mark allocations for factors, you will get those marks. So x and x. And then I need factors of negative 2 that can give me a negative 1 in the middle. Okay, or negative x in the middle. So that is going to be negative 2 and plus 1. So negative 2 times positive 1 gives you negative 2, but negative 2 plus 1 gives me negative 1. Okay, so x is either equal to 2 or x is equal to negative 1. And so those are my solutions for x. Now remember, we're trying to solve for x and y. So I'm going to go ahead and just call this equation 3. And now in order to solve for y, we can substitute equation 3 into the equation that has, oh, okay, we already had an equation 3. I'm going to call this equation 4, sorry. And now we're going to substitute equation 4 into the equation that had y as a subject, which is equation 3. So substitute equation 4 into equation 3. Okay, so equation 4 is this, y is equal to 2x minus 2. So taking that y equals to 2x minus 2. And I'm substituting 2 in first. And so that will give me y is equal to, that is 4 minus 2, which is 2. Okay, so we got that answer. Or y is equal to 2. And now we substitute the negative 1 in and minus 2. So y is equal to, and we have negative 1 here. 2 times negative 1 is negative 2. Minus 2 is negative 4. And there we go. These are our solutions for x and y. Okay, make sure to always do the simultaneous equation. It's really a nice way to score marks. You can see it's 5 marks. Okay, moving on to the next question. Okay, and now we're on 1.3, and 1.3 says we need to show that 2 multiplied by 5 to the power of n and then minus all of this. As you can see, this is an exponential expression, is even for all positive integer values of n. Okay, so it has to be even. We have to prove to them that it's always going to be even for all positive integer values of n. Okay, so first of all, let's just think about that. They say that n, first of all, is going to be a positive integer. It's always going to be a positive integer. Okay, keep that in mind. Then it has to be, this expression has to be even. For you to prove that an expression is even, you have to show them that that expression can be divided by 2. Okay, so for example, to tell you, or to show you that 10 is actually an even number, I have to show you that 10 can be divided by 2. I don't necessarily have to divide it by 2, but I just have to show you that it actually can be divided by 2. So the best way to do that is to show that there is a factor of 2 in 10. So to show that 10 is an even number, I could rewrite it as, okay, this is 2 multiplied by 5. And this will show, okay, that this is an even number because it has a factor of 2. Okay, so let's try and use these premises to solve this one. With this, we have that. So let me just put this on the side. Okay. Now, when we have this, we have to show that this is going to be always even for all the positive integer values. Well, to show that this is always going to be even, right now, it's a bit messy as it looks. So how about we simplify it so that we can finally see what this expression sums up to? What does it simplify to? So I'm going to take this and I'm going to attempt to simplify the expression. Okay, so when simplifying expressions, you should be looking for things like what can be added, can I factorize, things like that. Looking all through this factorization, because we definitely cannot add these, they're not like terms at all. To factorize this, well, I see a repetition of 5 to the power of n. See, 5 to the power of n again, and 5 to the power of n. So that you can clearly see this, we can break up these exponential expressions, these single ones. Remember the law of exponent that says that if you're multiplying two bases that are the same, then you need to add the exponents. Meaning if I had 2 to the power of x multiplied by 2 to the power of y, this will become 2 to the power of x plus y. So I'm going to separate those using that rule of exponents. So here I just have 2 multiplied by 5 to the power of n. I can't really separate that, it's just an n. But I can do that here, minus 5, and now this is what I can do here. I can call this 5, remember this minus is really separate from the 5, okay? 5 to the power of n multiplied by 5 to the power of 1. That's what gave you 5 to the power of n plus 1. And that's how I'm separating those. I'll do the same to this one. I have plus 5. And that is to the power of n multiplied by 5 to the power of 2. That's what gave us 5 to the power of n plus 2. Okay, now like this, you'd be able to easily see that 5 to the power of n is common in each term, in each of these 3 terms in the expression. So I'm going to take 5 to the power of n out as a common factor. This is a method of factorizing. So 5 to the power of n out as a common factor, open a bracket. In the first term, what do you have left? We have 2, so we just have 2 there. In the second term, what do we have left? Well, we have a minus in front. We must not ignore that. So minus in front. And then we have 5 to the power of 1, which you can just write as 5. Then in the third term, what do we have left after taking this out? We have 5 to the power of 2, okay? But we have a plus in front, so that's positive 5 to the power of 2. Okay, this is looking good because we have numbers all through here. So you can just go ahead and simplify that. So 5 to the power of n multiplied by all of that. So what is 2 minus 5 plus 5 to the power of 2? That's 22. Okay, so it's multiplied by 22, and this already looks good. When you can see that you have an even number multiplied by this, okay, which of course n is going to be positive integer values, but then like this, we can already see that this is always going to be even. But remember the rule that for you to show that something is even, you have to show that it can be divided by 2. So in order to show it can be divided by 2, you need to show them that it has a factor of 2 in it. So we can take out a common factor of 2 here. Remember, this is one term on its own. So I'm taking out a common factor of 2 from this term. If I take out a common factor of 2, this is 2 multiplied by, and then it's been multiplied by this. We still have the 5 to the power of n. If you take out 2 from here, that gives you 11 times 11. Like this alone, this is you telling them that 2 is a factor in this expression, therefore this expression is even because it can be divided by 2. And so this would be showing them that this is even. Okay, so I know that the question with showing that a certain type of expression is even, it also shows up in patterns, sequences, and series. Sometimes they give you the formula of the pattern and then it should ask you, show that it's always going to be even for every maybe positive integer values and so on. So to show that expressions are even, you have to show them that it can be divided by 2. The best way to show them that is to show that it has a factor of 2. Okay, and then we move on to the last question in question 1. Okay, so we are on the last question of question 1, and you can see question 1 is a total of 25 marks. So question 1 is really a place where you can score marks, and you should try your best to score marks there. The last question says determine the values of x and y if we have been given this expression. Okay, let me rewrite the expression down and let's just look at what's going on here. Okay, so this is the expression that we have. First of all, we have to solve for x and y. And as you can see, X and Y are on the exponents. So this is an exponential equation. With exponential equations, I'm already going to say this now. The goal is always going to be you need to try and to make the basis the same. Make the basis the same. I'll write that down. Okay, that is mostly your goal for exponential equations. So that's the same thing we're going to try to do here. Try to make the basis the same. Okay, to make the basis the same, this does look a bit messy. We have a square root, things like that. So because it's exponential, what we can try to do first of all, to make bases the same, you kind of need to have the numbers in an exponential format so that they have exponents. So this 32, I can change that 32 and put it in an exponential form. You can easily do this on your calculator by putting down 32, saying is equal to, then you're going to press shift, and then you'll see this button over here with the degrees and 3 commas, and has fact on top of that. And there it will factorize that for you. So we have 2 to the power of 5, that's 32. So I'm going to rewrite this as 3 to the power of y plus 1 over 2 to the power of 5. Okay, I'm trying to put them in exponential form. With this one, I mean, I can put the 96 in exponential form, but I feel like the square root is more of a problem right now, so we need to tackle that. So square root 96 to the power of x. The next thing, this 96, that root is a problem. Let's get rid of it. The only way to get rid of a square root is to square. And what you do on the one side, you must do on the other side. So I'm going to square both hand sides of this equation. And now we have this. Now remember the law of exponents. This is the third law of exponents. You learned this in grade 8. And this law, as you can see, this is an exponent. This is another exponent. It's been raised to another exponent. Okay, the exponents need to multiply into the exponents inside your bracket. So into those and into that exponent as well. So we're going to have 3 to the power of 2y plus 2 over 2 to the power of 5 times 2 is 10 is equal to, now over here, the root and that square cancel. So 96 to the power of x. Okay, now it seems like a good time to change that 96. So we can write 96 in an exponential format. So 3 to the power of 2y plus 2 all over 2 to the power of 10 is equal to, let's change 96. 96 equals, and we have shift fact. Okay, so it's 2 to the power of 5 times 3. So let's just be careful on how we write this. It's 2 to the power of 5 times 3. But then we still have the x, which the 96 is being raised to. Since this is now the 96, we are raising this to the x. Okay. So that x also has to apply to those exponents. On top of the 3, we have an exponent of 1, an invisible exponent of 1. The x is going to multiply to the 5 and the 1. So we have 3 to the power of 2y plus 2 over 2 to the power of 10 is equal to, and we're going to have 2 to the power of 5x multiplied by 3 to the power of x. Okay, this is what our equation looks like now. Not bad because you see a repetition of 3's and 2's. Okay, so how do we make the basis the same now that everything is in exponential form? Well, to make the basis the same here, you're going to have to try to, as long as the bases are the same, then it's fine. So I see 2 ways of doing this. You can either try to make this equation, say, 3 over 2 on both sides. So we could try and move this to the denominator, which would of course have an effect on that exponent. When you move something from where it originally was to another place, like a numerator or denominator, it will make its exponent negative. We could do that. Or we could take this to the numerator so that we can have a 3 multiplied by 2. Like here we have 2 multiplied by 3. That would be making the denominators the same. So I'm actually going to just take the 10 and move it to the top. So this is what I'm going to say. 3 to the power of 2y plus 2. And I'm going to bring this 2 to the power of 10 over to the numerator so that it can sit here with this 3. And when it moves there, it's being multiplied by 2 to the power of. Now that has an effect on the exponent because you moved it from the denominator to the numerator. The exponent becomes negative 10 now. becomes negative is equal to, and I'm just going to rewrite this as it is. This is, okay, let me rewrite it in the same order. Since we started with 3 here, I'll start with 3 here. And we can't do that because with multiplication, any way that you put it will still mean the same thing. Okay, multiply by 2 to the power of 5x. Now, you see we have 3 and 3, and they're both being multiplied by a 2. That counts as the bases being the same. It's not like it's saying 3 to the power of this plus 2 and then 3 to the power of this multiplied by. No, they have the same operation. They're being multiplied. So this counts as the bases being the same. So what we're going to do is equate the exponents, okay, with the bases that are the same. So the 3 with the 3. The exponent here, that's really like saying that means that 3 to the power of 2y plus 2 really is equal to 3 to the power of x, okay? Because you're saying 3 times something multiplied by 2 times something is equal to 3 times something times 2 times something. So they're definitely going to be equated and equal. And then we can say 2 to the power of negative 10 is equal to 2 to the power of 5x. Okay, if you didn't understand that, it's kind of like saying 3 multiplied by 2 is equal to 3 multiplied by 2. Right? So if I say 3 multiplied by x is equal to 3 multiplied by 5, and then here I said 2 multiplied by 1 is equal to 2 multiplied by 1, y, then it obviously means that, oh, okay, since they are equal, you're saying they're equal, and these two are being multiplied, it must mean that the x is actually a 5 for the equation to actually be equal. And that must mean that the 1 must also be equal to the y so that they can be equal. That's really what that is doing. Okay, so let's go ahead and equate the exponents. So it means that, therefore, 2y plus 2 is equal to x. And we have here that negative 10 is equal to 5x. So I'll go for this one because this one looks so much easier to solve. So negative 10 is equal to 5x. Divide both sides by 5. And so x is equal to negative 2. And now that we've solved for negative 4x, we could substitute x into this to solve for y. Okay, or you could just see that, oh, you have x, and you're just equating x and x. So I can just say, oh, okay, x is equal to x. So therefore, 2y plus 2, right, is equal to this negative 2, since they're both x. And now we have, okay, we can go ahead and just solve for y. I see there's a common factor of 2 all through. I could just get rid of it by dividing both sides by 2. So this is y plus 1 is equal to negative 1. Then I'm going to take the 1 over. So y is equal to negative 1 minus 1, which is negative 2. And there we go. We got x is equal to negative 2 and y is equal to negative 2. Okay, so that is it for question 1. And then we'll move on to question 2.